Introduction to progressive waves. When mechanical waves move through a medium, the particles of the medium are displaced from their equilibrium position. This displacement can be described by an equation known as the progressive wave equation. In this lesson, you will be able to interpret and use the progressive wave equation y equals a sine of 2 pi ft minus 2 pi x over lambda. Sketch and interpret displacement time and displacement distance graphs and use the formula phi equals 2 pi x over lambda. Click play. The interactive model shows a progressive wave being generated on a string by a mass spring system oscillating in simple harmonic motion. The resulting wave is of constant amplitude and frequency. The source of the wave is vibrating according to the equation y equals a sine of 2 pi ft, where 2 pi ft is known as the phase. Below the source, you can see a rotating phasor. This provides a visual representation of the phase. Use step through to step through a complete oscillation. Notice how the rotating phasor and source reach their maximum and minimum at the same moment. The particles along the string are oscillating at the same frequency and amplitude as the source, but with different phase. Click on P2. This particle is lagging behind the source by 1/4 of a cycle. We can also say the phase difference between P2 and the source is equal to pi over 2 radians. Click on P3. This particle is lagging behind the source by 1/2 of a cycle. We can also say the phase difference between P3 and the source is equal to pi radians. What is the phase difference between the source P1 and the particles P4 and P5? Answer: the phase difference between P1 and P4 equals 3 over 2 pi radians. The phase difference between P1 and P5 equals 2 pi radians. In this case, P5 lags behind the source by a complete cycle. We can say these 2 points are in phase. What is the phase difference between the source P1 and the particles P6 and P7? Answer: the phase difference between P1 and P6 equals 5 over 2 times pi radians. The phase difference between P1 and P7 equals 3 pi radians. The phase of each particle depends on its distance from the source. Phase difference between P1 and P3 equals pi radians. Distance between P1 and P3 equals 1 over 2 lambda. Phase difference between P1 and P5 equals 2 pi radians. Distance between P1 and P5 equals lambda. The general equation for displacement of a particle is y equals a sine of 2 pi ft minus 5, where phi is the phase difference for a particle at a distance x from the reference point. Phi equals 2 pi x over lambda. Therefore, y equals a sine of 2 pi ft minus 2 pi x over lambda. This is called the progressive wave equation. The minus sign indicates that as x increases, particles lag further behind the reference particle. In our model, the reference particle is the source. The progressive wave equation can also be expressed more generally as y equals a sine of omega t minus kx. Observe a progressive wave traveling in negative x direction. The progressive wave equation changes from y equals a sine of 2 pi ft minus 2 pi x over lambda to y equals a sine of 2 pi ft plus 2 pi x over lambda. The vibration of the blue particle leads vibration of the red particle. Use the equation phi equals 2 pi x over lambda to determine the correct phase difference. Rearrange the phase difference to correspond to the two given particles. From the completed table, observe that the phase difference between particle B and C is pi radians. The particles B and C are said to be in antiphase. A wave equation is given as y equals 0.3 times sine of 5t plus 8x. A. Determine the direction of propagation of the wave. B. Find 1. The amplitude, 2. The frequency, 3. The wavelength, and 4. The velocity of the wave. Click Solution. Summary. The progressive wave equation is y equals a sine of 2 pi ft minus 2 pi x over lambda. For waves traveling in the negative x direction, this becomes y equals a sine of 2 pi ft plus 2 pi x over lambda. If two particles are in phase, the phase difference between them is 0. If two particles are in antiphase, the phase difference between them is pi radians.